Good morning. I'm Hayat Gallo. I'm the Executive Vice President for Security at Microsoft. Delighted to be here today in San Francisco with all of you. And thanks for the folks joining online. So I am an engineer by trade and by training. And for me, it's always about the equation that you're solving, how you connect that technology you're working on to the business outcome for customers. And I feel very privileged to be back at Microsoft and to work on security again. And the security equation has gotten much more complicated than it used to be. And today our customers actually have to make a choice between innovation and safety. And that is not acceptable. So when you think about that equation, what is changed, right? What is happening between defenders and attackers? Well, AI is happening. It's happening at scale, and it's changing the game. So let's take a look at what it looks like now with AI and attackers. This first example that I took was an example to show how attackers who 9 months ago were using AI-assisted operations are now actually shifting to AI-executed operations. So what do I mean by that? In this example, you have a Chinese actor who targeted 30 customers in technology, in financial services, and governments. The entire campaign was AI-driven, 90% of that campaign, from the moment you do your reconnaissance, that you find a vulnerability, that you try to build your exploit, that you actually take the credentials, and then you move through the environment and you build that backdoor and do exfiltration. Well, guess what? 90% of that was AI. The humans was just directed those agents, right? And those agents, 15,000 requests a second. A scale and speed that a team of humans cannot scale to. So this is the reality of our customers. AI-operated execution now happening. Now, you could say, well, this is already scary. It's true. But now we've moved to another layer of sophistication. We're moving from AI-operated execution to actually AI autonomous execution. So here I picked an example. In this case, what the actors actually did is they built a bespoke tooling, 17,000 lines of code, 49 modules to target the customer's environment. And this was not a fixed like malware package, not fixed at all. AI just adapted throughout the entire attack. It corrected failures, it built new capabilities as it was moving through the customer's environment. As you can imagine, for defenders, the way we defend is we know of certain signatures and techniques, and that's how we find the attackers. What do you do when these things keep changing? This is the reality, and this scenario is just illustrating how with AI, we're now evading detection. So if you think about it, we're now in a world where we move from AI-assisted attacks to AI-operated attacks to now autonomous AI attacking customers. The physics of cyber have fundamentally changed. This is no longer the same game. And what we have now with AI is we have attackers having a symmetry and advantage over the defenders. Of course, it's not okay, and we need to make sure that the defenders can defend at the scale and the speed of the attackers. So we believe that to do so, you need a new cyber stack. A stack that is built on top of the security foundations that you had. So we built it. This is what we call perception. Perception is our agentic security system that is designed for defenders to defend against AI with AI at the scale and speed that the attackers have. So let's take a look at what we mean. And by the way, perception is actually going in preview on August 3rd for all of our customers around the world. So we're very excited. So what do we mean by a stack? So this here is the signals. So you think I said we are building on the foundation of security. So today you have security signals. We at Microsoft sit across your identity, your data, your threat, your cloud, AI, and your code. So we see a lot of signals. You add to that our security research, our threat intelligence, our red teaming efforts, you get even more signals. I think we talk about 100 trillion a day of signals. And that sounds very impressive. It's impressive. But if you were to apply agents on that raw data, you wouldn't get a good result. That will be actually terrible. It will also be very costly and very slow. So what we've done is we are basically taking all those signals and we are connecting them and correlating them so that we build what we call a security context. That security context is organized efficiently for agents. We basically create a security graph. This becomes the shared understanding for agents. And this is how basically we ground every interaction. As a result, because of that security context, what you get is not only do you get accuracy, you get consistency in the reasoning and the results, but you get actually savings from a cost point of view, and from a speed, you're much faster with your agents, right? Now, it's about building the harness and the agents that are gonna run on top of that rich data to make sure you can actually drive outcomes for customer. We believe in a multimodal approach, optimized for the security workflow. We will match the right model to the right security task. And at Microsoft, we have security team, and they actually evaluate all the models that you can find out there. And we look at which ones are gonna get us the best results. The reason we do that is, number one is we want the best quality. Number two is we wanna make sure that this is affordable. Security is a 24/7 operation. So you need to make sure that this is scaling. And last but not least, the reason why we're multi-model is that not every model is available everywhere. So we need that diversity of model to make sure that every customer can defend itself. We cannot be in a world of haves and have-not. Everybody needs to defend itself. Now, in terms of what's the next step, we're building this harness and those agents. You're gonna see 3 types of agent in that family of agents. We call them the red, the green, and the blue agents. So let's go through those agents and what do they do? We have the red team. These are agents who attack the environment. They look for the attack path and see whether you have vulnerability to specific attacks. The blue agents are the agents that defend, they investigate, they look for to reason over the data and whether they should take action. And the green team of agents is all about making sure we fix your environment, we harden your posture. Those agents, it's multiple agents, they work together in a loop of defense. Around the clock, it's about attack, defend, and harden. So I could talk more about this, but I thought we would share with you the experience of one of our customers nationwide who is today using perception. But before we do that, because I always go ahead of things, I would just say, just know that we have been working with them for a few weeks and months, and we're very excited with the results we're seeing. Over to you, Nationwide.
Here at Nationwide Building Society, we're a mutual organisation, and that means we're owned by our members. We're a core part of the UK economy, so it's really critical that we can defend those customers.
The things that matter most is protecting their money, protecting their livelihoods. We need to make sure that those things are safe.
Artificial intelligence is changing the threat landscape. It is giving attackers a real advantage over defenders.
With perception, we can be more proactive within our environment.
Red agents are offensive cyber agents used to explore the vulnerabilities in the attack paths in our environment. Blue agents are the defensive agents and reflect the work that a security operations center analyst might do. The power of the solution is it brings those agents together to achieve a better cyber security posture.
We're able to use agentic workflows to identify threats and then track them through into remediation, which previously we would have had to have engaged with a number of different tools to achieve. We've been using Microsoft Defender for a number of years, And that means we can integrate these multi-agent capabilities seamlessly within that product set.
My team came to me and said, look, we've just taken 4 weeks of threat intelligence analysis and collapsed that down into just 4 hours. And for me, that was the moment that really brought this solution to life.
We've got a team of real experts in our cybersecurity response teams. I don't want to lose that. And this technology helps to amplify their skill sets, not to replace them.
Agents can work 24/7, but as humans, we can't do that. So by harnessing human and agents operating together, we can achieve so much more collectively. Being able to develop this solution together with Microsoft allows us not just to protect nationwide building society, but also to protect wider society, and that feels really positive.
You know, what I love in this video is 4 weeks in 4 hours. That's really what we're aiming for, really helping the defenders to scale effectively. Because you always want a human in the loop in security, but you want to make sure they're empowered to do their job. So at this point, I hope you're excited and that you actually want to see the product in action. So I'm delighted to bring on stage our engineering leader for perception, Dave Weston.
Everyone. Thank you, Hayat. So I am super excited to show you perception. This is what we believe is agentic security evolved. It's multi-model, built on the stack that Hayat showed you, long-running, autonomous teams of specialized agents that are designed to get work done across the estate. We believe fundamentally you need agents to fight agents, and we're empowering our practitioners to do that. So to give you an idea of how the product works, you can see what are called playbooks here. Playbooks are very similar to the way humans run their SOCs. They're sets of operations that are done to achieve an outcome in a standardized way. In perception, that work is done by teams of agents, red, blue, and green, as we talked about. And not only can you run on these playbooks, and there's many more, you can simply type in and ask these agents to get work done for you. So let me give you an example. This is something that's happened to me many times from CISOs and CEOs alike, and that is a new threat intelligence report drops, and there's a fundamental question. Are we protected from this adversary? Normally that takes hours and hours of your best people coming offline from strategic work to doing a bunch of tactical code tapping. With teams of agents, you can get that done in less than an hour simply by tasking them. So let me show you how simple this is. I can just click here and ask, is my organization protected against Onyx Sleep? Onyx Sleep is a threat actor that we're interested in. And our teams of agents will go to work. So I'll trigger that here. The first thing that happens is the perception main agent figures out what playbook should run here based on the task requested, and it selects the right team of agents. So you can see there's some blue defense agents, there's some red agents that will do reconnaissance and pen testing, there are green agents that will help with remediation and or blocking. So let's kick this off, start the session, and right away we go to work, we get a session report, and we get a set of indicators that immediately come from the threat intelligence agents, and we've queued up a reconnaissance agent to look at our attack surface. So the first thing we'll start with is let's see what threat intelligence actor, what we found out about Onyx Sleep. So we'll click here, and right away we get a few IOCs, you can see some IPs, some domains, even some file hashes. This is really cool. It also tells us what this attacker does. And right away, we'll take that information and we'll pass it off to a red agent. This is your attack simulator. What the red agent is going to do is take this information and say, hey, if I was Onyx Sleep as an agent, they're going to pretend to be that agent. How would I hack in or how would I breach? So we'll continue that run here. You can see right away, we've done a couple of cool things. We've taken the IOCs from the previous instance, and we've said, hey, there's a billing application that's available. Why don't we look and see if this is exposed? Why would we do that? Well, Onyx Sleep likes to target web application vulnerabilities, and we know one is exposed here from the reconnaissance agent. So the next thing we're going to do is pass this information off on how Onyx Sleep would get in to a pen test agent that's going to actually evaluate that billing application and figure out if it could be compromised. So one thing I want to note here is it's actually asking for our permission. Why? Anytime you have an interesting operation, we want to make sure the human's in the loop and control of this. So we'll simply allow that to happen and we'll submit. Now, we'll hand it off to the web pen test agent. And the first thing it did is start to pull up some vulnerabilities that were found by our Agentic Vulnerability Discovery System, or Mdash, which uses teams of agents to do code scanning. Now, that system is so effective, it often finds dozens or even hundreds of vulnerabilities in an individual application. And usually your first question is, which of these do I fix first? But what we've done here is actually take that information, we've handed it off at real-time or runtime to a web pen test application, and what it's able to do is assess those dozens or hundreds of vulnerabilities into the few that you should fix first, and even more, the few that this actor is likely to target. So you've gone from this large funnel of potential risk into a prioritized set of actualized risk, which saves you time and makes your defense more effective. So we'll check on the vulnerabilities here, and you can see that the red pen test agent has actually found a few. It's tested a finding from Mdash and found, yes, this SQL injection is real. It's exposed to the internet. We've got a cross-site scripting, a very common vulnerability, and an identity vulnerability. So we're cooking with fire here. We know what to do and what to go and fix, and we'll close that out. Now, one of the most important things is many systems stop here. They're great at finding problems. But what's really cool about perception in these multi-agents teams is we can go from just finding problems to fixing them, which is ultimately what our customers want. So we'll move on to the next step. We'll invoke a blue agent. This is our defender's agent. And what it's going to do is actually write custom detections for each of those vulnerabilities. What this is going to allow us to do is make sure that we have alerts that we can monitor and detect anyone potentially trying to attack these specific vulnerabilities while we buy time to fix this. Sometimes it takes some time to build a fix for the application, certainly to get it tested and deployed, and we want to make sure that we have detection and coverage. So this is the first step in remediating the issue. These custom detections are actually written by coding agents through this multi-model system, and they're written in a language called Custo Query Language, or KQL. So this is a coding language. Often, folks that are in the SOC might be security experts, but not coding experts. So these agents are really empowering because they allow you to write code where you might not be able to do so. So we'll continue to the next stage of remediation. We're going to get our green agent involved here. This is our fixers. These are the green agents will do remediation, so they might close ports or change firewall issues. Again, this is all part of addressing the threat. So now that we've got the detections in place, the next thing we want to do is potentially block any intrusion. And we have a remediation plan from the green agent. It suggested we can use a web application firewall to block it. We can also turn that into blocking mode, and we can even add an authorization check. So this is great. This is our second layer of defense against these attacks from this particular adversary. And now we'll move on. We'll close this out. And we'll move on to the next step, which is actually producing a code fix. Again, many of the folks in the SOC are not necessarily the code folks, so we're empowering them here. We can actually write fixes with agents, and we can look into them. So here's an example of a fix that we've produced, and we can even edit it here if we know how to do that. The code fix is here. We can look through that, which is super awesome. We even get examples of tests we can add to validate this. That is super great. So now we'll close that out, and we can just say, hey, I'd like you to volunteer to fix this. So you click yes here, submit. And I can even chat with the agent and say, I'd like a notification if this pull request is accepted, and I'll get a notification back from the perception system. So this is pretty great. So we've gone from this taking hours and hours of manual work from multiple specialized folks across the security organization, AppSec, hunters, remediation engineers, you name it. And in minutes, we have a fix for all of this. Not only have we discovered the issues, prioritized them, but we have detection, posture fixing, and even a code fix. So this can save hours and hours of time. Now this is super cool. The next question you might have is, hey, many of the folks out there that are leveraging AI actually work in command line interfaces or other types of applications. So we have actually produced what's called an MCP or tool plugin that allows you to use this from CLI systems, so we meet folks where they are. We also have a Kanban system in perception that allows you to manage work. So not only can you manage work from multiple systems, but you can actually kick this off in a command line interface. And what I've done here is actually run the exact same query. And what I'm showing you is that one-to-one whether that comes from the CLI interface, an application like GitHub Desktop, or even Claude, you can manage perception wherever folks are at. You get synchronization. That has the benefits of governance, identity, and auditing, which is super awesome. Now, the last thing that I'm super excited about is because this is in the CLI, we can actually also run many of the basic tokens that are not related to security on any model we want. And we actually built this demo on an NVIDIA Spark RTX, which is a Windows device, and it's, yes, absolutely. And it's actually very safe because it's running in execution containers. So this saves you on efficiency where you don't need expensive tokens in the cloud. You can actually run this in unmetered intelligence on a choice of models. And this is super helpful for engineers out there that are running in the CLI. And with that, I'm going to hand it back to Hayat. Thank you, everyone.
Dave. Thank you, Dave. As you can see, what we went from is threat intelligence insights all the way to understanding, is your environment at risk, to actually then going and fixing, not only like building detection and defenses, but then going all the way into the environment and making changes. This is what's important because customers don't want more alerts. What they want is protections. So we went from insights to actions right there within the perception tool. Now, we showed you threat intelligence into actions. Another vector of attack is software vulnerability. And I think in the last few months, we've all heard and seen the headlines, mythos, all kinds of headlines, right? And everybody is worried and everybody's thinking about vulnerability. Our code name for software vulnerability team of agents is called Mdash. So within perception, you saw Dave was taking the output of our software vulnerability team of agents. And so basically think about Mdash as a code name for a combination of red and green agents. And what they do is they scan the repos of our customers. They look at, is there vulnerability? We validate that are real, that you can actually exploit them. We prioritize them, and we help you remediate this. This is a very important tooling because this is a vector of attack. Now, we built Mdash for ourselves. We at Microsoft had to scan a lot of code, as you can imagine, and we had to get very efficient and make sure that we didn't create toil for our developers. So that's why we built Mdash internally. And then we decided we should give that to our customers because they're facing the same problem. So Mdash is fully integrated with perception. It's our red and green agents for software vulnerability. Because we had hardened that at Microsoft, we were actually, when we released Mdash and it was tested on the Cyber Gym, which is the major benchmark for this kind of application, we topped the benchmark. We showed that you didn't need to have those very advanced model. We were able to take off-the-shelf model within our harness, a multi-agent, a multi-model implementation, and we achieved the best results you could have. So I thought it would be worth showing you what actually Mdash looks like, since it's top of mind for every customer in the world. So I'm delighted to welcome Dustin Duran. So Dustin is our engineering leader for Mdash. Dustin, welcome.
Hello. So while organizations code has always been on the attack surface, Hayat showed us earlier how attackers are using AI to find and exploit vulnerabilities before defenders can address them. Mdash protects this attack surface. It connects SecOps and DevOps together in a loop by finding vulnerabilities, validating that they are real, and helping developers fix them. Let me show you how Mdash moves a vulnerability from discovery to resolution. So as a security practitioner, I want to start with the big picture. I want to understand overall organization-wide code risk. I want to understand progress. I want to understand the state of my software assets. I begin by understanding what code is being scanned. Here you can see, I can understand what repositories, what branches are being scanned. But more importantly, the prioritized vulnerabilities that Mdash has validated are real and reachable by an attacker. Now, I don't want to just dive into these right away. First, I want to understand the systemic patterns so I can resolve those patterns with better speed and scale. Here you can see the most common vulnerability classes in my code base. Effectively, what are the mistakes we are making most frequently? I can also see the severities per code repository. So I can understand what code base is most at risk. Building from this big picture view, I'm going to want to understand the details to allow me to help best connect with my developer colleagues. Switching to the security recommendations view, I can drill into a vulnerability and understand its complete summary. Most notably, the impact, but more importantly, the attack path. Here you can see our team of agents is working together to explain why this vulnerability is real and how an attacker would reach it. As you can see, this information is incredibly powerful, and it is incredibly important that it is kept secure. In the wrong hands, this could become the blueprint for attacker exploitation. Switching to our unified role-based access control, I can use permission groups to safeguard this sensitive information. We've created new granular controls that allow me to restrict the right roles and permissions for each audience, controlling who can run scans, upload results, and view and manage findings. This flexibility enforces least privilege by design, ensuring Mdash is tightly controlled in terms of who can access the capabilities and the results. So I showed you how I can use my practitioner workflow to be able to understand and prioritize risk. But ultimately, developers are going to be responsible for fixing the vulnerabilities. Mdash is multi-surface by design. It meets developers within their workflows via ecosystem integrations, including GitHub and Azure DevOps. In addition to what we saw earlier regarding the impact and the attack path, Mdash is going to provide developers concrete code changes together with an explanation of how this addresses the threat. Developers can see the before and after. They can automatically kick off pull requests, and they remain in control of any code changes that are happening. This is the language that developers work in every day. Red is code removed, green is code added. The verification plan helps make sure that after the code fix has been made, that the code is no longer vulnerable. Look, I've opened thousands of security bugs in my career, and the hard part's not opening the initial ticket to get developers to go investigate. It's actually getting the code fixed and fixed correctly. This is why I'm so excited about Mdash. Yes, it's meeting SecOps and DevOps in their respective workflows, but by connecting those groups, we are greatly reducing the time from vulnerability discovery to correct resolution. And that is changing the equation against attackers. Back to you, Hayat.
Thank you. So as you can see, productizing means we actually put it in the enterprise hands and made sure that not only are we enabling security professionals, but developers as well, because this is a full loop. You have to find the issues and then you have to fix them. Now, we feel good about, and you have to have control and trust. You can't leave those things in the open because you give otherwise a map to attackers. Now, we feel good about the progress we've made on Mdash. At the same time, one of the key feedback we've had from customers is they have a lot of repos. And they want to make sure that as they're scanning and finding those vulnerabilities and fixing them, they want to make sure that it's cost effective. So I talked earlier about multi-model approach, right? We're always trying to find the right model for the right security task so that we can get the right results, but also be cost effective. So in that context, we at Microsoft happen to actually build models. We're committed to an ecosystem and multi-model approach. We also have our MAI models. So I'm delighted today to announce that we have been working with our MAI team, and we're now bringing our new cybersecurity model, MAI Cyber One Flash, within our harness and Mdash to actually continue to help our customers not only have great quality, but also have affordability as they run this very important job in the SOC, which is software vulnerability. And to discuss this, I'm delighted to bring on stage Mustafa Suleiman, who is the CEO for Microsoft AI. Mustafa, welcome.
Hey, hi, good to see you. Hello, everyone. Morning.
Hi, sir.
Magic. Cheers.
Cheers. That's now full. So Mustafa, we're committed to a multimodal approach at Microsoft. We're also building our own models. Maybe can you tell us, like, why we're doing this?
Yeah, I mean, I think from our perspective, the most important thing is that inside of the harness and the products that we build you have access to the very best models in the world, wherever they come from. At the same time, we absolutely know that over the next 2, 3, 4 years, the model is going to become the product. So the UI, the logic, the data structures, the code is increasingly going to be internalized by the model itself and optimized for the harness that it's delivered in. And so from a Microsoft perspective, we know that it's mission critical that we both have the capacity to train models that are at the absolute frontier in-house, but also that we can tune our models precisely and specifically to the products that we want to serve you using reinforcement learning and collecting vast amounts of feedback on behavior and performance in production. And that allows us to have control of both cost and quality, which is fundamentally what everybody cares about. And that's why we have a very broad and diverse fleet of different models that are suitable for different tasks. Now, on that topic, I thought maybe it'd be useful to ask you, Hayat, about reinforcement learning. I mean, we have a tremendous amount of data across the company. I mean, you've experienced this many times in different settings, both at Google and beyond. Having now looked at the data that we do have and the feedback loops that we built, tell us a little bit about what you think we have in terms of this asset.
Yeah, I think what's exciting and why I think we can really have an impact when we partner together for security practitioners is that at Microsoft, yes, we have a large reach signal set, right? And you saw that at the beginning of this session. But at the same time, what's really important is we don't only have signals, we actually see what is happening. We see when you have an action happening. We see when somebody is trying to remediate, investigate, when they try something, did it work or did not work? It's like this live learning environment that can feed back into what you're building so that we can really be very capable, very accurate, but also do it effectively. That's why I was so excited when we partnered together. So now, Mustafa, we said we have the learning environment and reinforcement loop. We worked with you. What kind of results did we get?
So we're very, very excited to announce our results. And so we have MAI1 Cyber Flash combined with GPT 5.4 inside of the Mdash harness, which beats out Gemini, GPT 5.5 Cyber, GPT 5.6 Sol, and Mythos 5 on Cyber Gym, which is the primary benchmark that we all use, the golden benchmark. Now, this is really quite a remarkable result. We have optimized both our models and the harness such that MAI Cyber 1 Flash handles about 90% of the queries. It detects the vulnerabilities, it patches them, ships them, and then proves that it was actually a valid and correct solve. And then it basically defers about 10% of the queries to GPT 5.4, which is obviously a larger model, about 10x larger, and it solves those. So in conjunction, as the models hand off between each other, they're actually not just able to deliver better performance than all of the other models combined. They do so at 50% of the cost. So we have world-leading performance at 50% of the cost, which is driven by this combination of models and the expert-tuned harness that we have in Mdash. And I think it really speaks to two very important things. Microsoft has long been the trusted steward of some of the most valuable and important government and enterprise data in the world over many decades. We've accrued a phenomenal amount of data in that time. And it's that data combined with the expertise that we have from the world-class cybersecurity experts in the company that we've been able to really drive this combined model and harness impact.
Yeah.
So obviously, these results are pretty cool and they're very exciting, and we're shipping this into production immediately. Maybe Hayat, tell us a little bit about trust and safety. Like, how are we going to govern these things, make sure that they consistently do what you want them to do and no more, and make it
boring
practical?
stuff,
The boring
stuff that we
stuff.
need, right? So I would say, look, we serve 1.6 million enterprises, so we have been working for years to understand what trust means. You saw in the Mdash demo the controls we've put in place so that when you get the results, they're safely stored, only the right people can access this. And of course you will get that because MAI Cyber One is within the Mdash harness. The other thing is, when we release such solutions, within our security team, we have a red team group and a safety team, and their job is to attack the model and to make sure that we find any vulnerabilities before we ship. And so we make sure that from the moment we're training the model to shipping to customers, at all the layers, we've actually put the right trust and controls so that it can be safe. So that's why we're very excited to release this. We feel it's capable, it's cheaper, and it can be trusted.
Well, I think one of the exciting things, by the way, is that we have really just started on this journey, and we've used a fraction of the training data that is otherwise available to us across the company. And given that we've really only just started to close the feedback loop with putting this into production with some test users, the scope for improvement is enormous. So I'm very excited about what's to come.
It's enormous, and if you think about perception, we picked one scenario right now, which is software vulnerability, and that's what we've been collaborating on. But you've seen a lot of different agents running in Dave's demo earlier, and you're gonna see us looking at how we extend MAI Cyber One Flash in many of the workflows that you have to perform as a security practitioner. So we're very excited about what's coming next, but already you can take advantage of that software vulnerability harness and leverage MAI Cyber One.
Yep, lots to improve along the way, but that's the bar that we've set for ourselves.
Yeah.
It has to be higher quality and cheaper simultaneously. So really looking forward to everyone giving us feedback on it as we improve and iterate and deliver the best that we can.
Thank you, Mustafa.
Thanks a lot, Hayat. All right, take care.
So as you've seen, we are able to achieve very high performance, right? 96% on the benchmark, and most of the market is at around 83%, right? And we are able to do that at half of the cost of our previous configuration on Mdash, and we're gonna continue to hill climb on this. Now, this is very important, but if you think about it, how do you get to that kind of results? Like, it's not just about the models, it's not just about the security signals, it's about those teams that we have, that security expertise that Mustafa was talking about. Microsoft, we have Microsoft Security Research, we have our red teams, we have the folks who manage the services, we have our MSRC team. All this is coming together to inform our innovation. And if we want perception to be capable and helping customers across all their scenarios, this is a fundamental ingredient. You gotta feed perception with the right insights and innovation. And if you think about Mdash, just to give you context, he came to be because of a team we hired who happened to win the DARPA award. So the DARPA had a contest that was about code security. The team that won that award, we hired them. We hired them to the company, and that's how we got to the kind of results we got into. And you're gonna see us continuing to really make sure we bring the best-in-class talent in Microsoft security so that we can continue to innovate like we've done with Mdash and across perception. And so to discuss more about what we are going to be doing in that context, I'm delighted to welcome Dr. Tae-Soo Kim. Tae-Soo was the leader, is the professor who was leading this effort and who won the DARPA award with his team. So Tae-Soo, welcome.
Thank you for having me.
So Tae-Soo, I heard there were 40 teams in the DARPA award. So what does it take to win such an award?
You know, DARPA has been organizing a grand challenge whenever they recognize a societal problem. Self-driving car challenge 20 years ago. 20 years ago, we started to see a lot of progress. But the challenge is that we have to keep pushing the limits. And 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 we have to keep pushing the It means cybersecurity, thanks to recent advances in AI frontier model, is one of the most important challenges today. All the team participating in this competition brought their latest technology and research. The thing that we did pretty well is to strike a balance between engineering and high-risk, high-return research throughout the competition.
So you win the DARPA award, and you think about what's next. What was in your head?
I think after AI Cyber Challenge, all the teams, all the winning teams in DARPA has been discussing about what's the best way to make these amazing new technologies available beyond this competition environment. I think I can think of any better place than Microsoft. You know, Microsoft Azure and GitHub represent about 80% of entire source code repository in the world. We literally call this a real-world AI cyber challenge. And we really like the opportunity that Microsoft provide to us, and really proud to be here.
Well, thank you, because it's exciting. We've already productized this. Now, I know you're always thinking, and you're thinking what's coming next. So what's cooking right now?
I would say complete autonomy. This is the key to solve the scalability and speed challenges that we face in AI vulnerability discovery research. There's still lots of important challenges and research problems that we have to solve, but that's why investing at the intersection of AI and security is so important.
Yeah, I mean, the pace of findings right now is outpacing the ability of people fixing it. So autonomy and getting this cycle to be faster is going to be fundamental. Now, you and I have been discussing, and you came to me with a proposal. Do you want to tell us more about what we're doing?
We have one great news to share. We'd like to introduce Microsoft Security Forge Lab. Our mission is exactly this. We like to tackle the scalability and speed challenges we face with the two goals. First, we like to advance the frontier of the offensive security research. Second, we'd like to accelerate the evolution from AI-assisted vulnerability discovery to autonomous security research.
Well, I'm very excited, and I'm very excited that you're going to lead this effort for us. And you're going to bring all this talent to the company and structure that research for us. Thank you, Tesu. So as we've seen, right, we're in a world now where attackers have AI, and the equation is not balanced. There is a ton of asymmetry. And so really, I hope what you got from today is that our goal, our mission is to make the world a safer place, and it's about balancing this equation. And so welcome to Perception, and thank you for listening today.